All right, welcome back, everybody. Now we are going to start part 2 of quadratic functions with the goals in mind of the quadratic formula. And applications. All right, so the quadratic formula, chances are you've seen it before, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so if it's just a matter of putting the numbers in and doing the calculation, that's something you've done before. I want to do that, but I also want to look a little bit deeper into the quadratic formula to see if we can learn something that maybe you haven't talked about before. And the aspect of the quadratic formula I'm talking about is the discriminant. All right, and the discriminant is b squared minus 4ac, which is under the square root symbol. All right, so if the discriminant, b squared minus 4ac, is greater than 0, you know something about your solutions. You have two real solutions. 0, two real solutions. If b squared minus 4ac is equal to 0, you have one real solution. And if b squared minus 4ac, sorry, that should be a c, is less than 0, you have no real solutions. All right, and this could be helpful, number one, because, in my class, we're looking at real solutions only, which means that if your discriminant is less than 0, that's enough work to tell me there are no real solutions to that particular equation. All right, but also it can inform you, are you looking for two solutions? Are you looking for one solution? And if you know you're looking for two and you get two, you can feel just a little bit better about your answer. All right, so let's take a look. All right, so what do we have here? I have solve. I have 3x squared equals 5x plus 2. Okay, this is indeed a quadratic equation. That's the first thing you need with the quadratic formula. It needs to be a quadratic equation. People like to use the quadratic formula when you have x cubed as your leading term or x to the fourth as your leading term. You can't do that. You need to have a quadratic equation. The second thing you need to do is you need to bring everything to one side. So you could rewrite this as 3x squared minus 5x minus 2 equals 0. All right, this is the way to find out what a, b, and c are. All right. All right, now, here's the deal. I find factoring much easier, much quicker than the quadratic formula. So if it can be factored, I would suggest doing it that way. All right. I'm not going to check for factoring because we're in the quadratic formula section. So I'd like to do the quadratic formula here. All right, so once I bring everything to one side, then I know that a equals 3, b equals negative 5, and c equals negative 2. All right, now I can start putting things into my quadratic formula. All right, so I'm going to start with the discriminant of b squared minus 4ac, and that is negative 5 squared minus 4 times 3 times negative 2, which is negative 5 squared is 25 negative 4 times 3 is negative 12, times 2 is positive 24, so that equals 49. 49 is greater than 0. So my expectation is I have two real solutions. All right? So now let's use the discriminant I just got to say x equals, so negative b is 5 plus or minus the square root of 49. I don't need to redo the discriminant. I already did it. Divided by 2 times 3, which is 6. All right. So I have 5 plus or minus square root of 49 is 7 over 6. So then I have 5 plus 7 over 6, which equals 2. And then I have 5 minus 7 over 6. Negative 2/6, which equals negative 1/3, right? This plus or minus means I have two equations here. I have 5 plus 7, 5 minus 7. So I have two real solutions. So my solution set, you can have those squiggly brackets, is going to be 2 comma negative 1/3. Okay. So let's take a look now at an application. All right. So a farmer wants to build a rectangular grazing pen using a straight stone wall for one side. He has 100 feet of fence for the other 3 sides. What's the maximum area that can be enclosed? What are the dimensions of the pen? So again, anytime you see the word application, it basically is going to mean a word problem. And while you may not be a farmer, this is a wonderful application for a man who owns a farm, because, right, if he's going to build a pen like this, he most definitely wants to maximize the area for his animals. So if this is a rectangular pen, then these two sides are going to be the same length. We'll just call them x. Now we have a total of 100 feet of fencing. I'm subtracting off x and x. So minus 2x is going to be for that third side. So this would be 100 minus 2x. All right. Now let's get to work. So if that's the dimensions of our pen, our area is length times width. So it's x times 100 minus 2x, or 100x minus 2x squared. Now this is indeed a quadratic equation. Even though the 2x squared comes second, it's still the highest power in the entire equation. You could easily reverse this to say negative 2x squared plus 100x, and it would look more aesthetically pleasing. So this is not only a quadratic equation, but we know that this is a parabola that opens down. All right, and if it opens down, the highest point on this particular parabola is going to be the vertex. Hang on. All right, so if we want to maximize our volume, we certainly need the biggest point that the biggest number x could be. All right, so in order to get our x value of our vertex, I have to do negative b, so negative 100 times 2 times negative 2, right? Which is negative b over 2a. So I have negative 100 divided by negative 4, which equals 25. That is the largest x could be. All right. So I can now take my drawing, instead of putting 25 and 25, or x and x, I could put 25 and 25. And then 100 minus 2 times 25 is 50. So this could be 50. Therefore, the dimensions of the pen, right, the dimensions are 25 feet by 50 feet. And the area of the pen would be 25 times 50, which would be 1,250 feet squared. All right, it's a short part 2. There is a lot more practice to go. I would do a variety of problems to get, like I said, get yourself a little bit more experience. Thank you guys for listening, and I'll see you all next time.